Today we're going to be talking about medians, altitudes, and perpendicular bisectors. And a lot of this we've already discovered in our Sketchpad Explorer, but either if you were absent or you need a refresher or another explanation that you don't remember from class, here's our video. Okay, medians, altitudes, perpendicular bisectors. So the definition of our median is a segment in a triangle from a vertex to the midpoint of the opposite side. So our medians intersect and they go from a vertex to the midpoint of the opposite side. And the point of concurrency, and that's a straight line, of our medians is called a centroid, and I want you guys to know that. And the centroid is always inside of our triangle. Altitude is perpendicular from the vertex to the line that contains the opposite side. So in an isosceles triangle, that vertex or that altitude bisects this opposite side. Remember, if this was an isosceles triangle. In a right triangle, that's an altitude, and that's an altitude. Just keep in mind that the legs are also altitudes. And then in an obtuse triangle, your altitude from this vertex perpendicular to the opposite side, a lot of students see, because it's the line that contains that opposite side. This one they see, but this altitude from here connecting to this other side, the line that contains this other side, a lot of students struggle with seeing because you have to extend that and it extends down this way. Okay, so our point of concurrency, this is called the orthocenter. And the orthocenter is sometimes inside of our triangle. If you have an obtuse triangle, it's going to be outside. If you have a right triangle, our orthocenter would be right there. If you have an acute triangle, it would be inside. Now, a perpendicular bisector is a segment that is perpendicular to a segment at its midpoint. So if AB is the perpendicular bisector of XY, M would be a midpoint, and we would have two right angles. And remember that a point lies on our perpendicular bisector. It's equidistant from the endpoints of this segment. So if you have a segment and you have your perpendicular bisector, where those are equal, any point on this perpendicular bisector is equidistant from the endpoints of the segment. And then if a point is equidistant from the endpoints of a segment, so if you have a point up here, and when you draw, and we're equal, that point is going to be on the perpendicular bisector of our segment. So the point of concurrency of our perpendicular bisectors is called the circumcenter. And hopefully you remember from our Sketchpad activity that the circumcenter of a triangle is sometimes inside of our triangle, and the circumcenter, since our perpendicular bisector, so if I draw in my perpendicular bisector super quick here, I kind of cheated on that one. So there's my point of concurrency. This point is equidistant from the endpoints of those segments. So it's equidistant from that vertice, from that vertice, from that vertice, from all three vertices. It allows us to draw a circle through all three vertices. And that's a circle, I promise. And this is going to become super important to us next semester when we get into constructions. Okay, distance. And I talked about this a little bit. Distance from a point to a line is a perpendicular segment. That's the shortest segment that we can draw to our line. So it's the shortest distance. When we talk about distance, that's our shortest distance. Okay, some examples. So if AB is equal to BC, then B is going to be the midpoint, making PB the median. If PC is our perpendicular bisector, then PC equals CD. Well, if PC is the perpendicular bisector, our two segments that were equal were PC and CD, so therefore it's the perpendicular bisector of BD. Okay, if APD, if I have a right angle in here, then what are my altitudes? Remember I talked about how the altitudes in a right triangle are the legs. So AP and PD are going to be our altitudes. If PC is the median of triangle PBD, if this is the median, remember the median goes from a vertice to the midpoint of one side, therefore PC has got to equal CD. So if PC was equal to CD and PC is perpendicular to BD, then, okay, what is the perpendicular bisector of what? So what line intersects at the midpoint? PC intersects the midpoint of BD, so PC is the perpendicular bisector of BD. Okay, PC and AC are both altitudes of triangle PCA. So this is an altitude and this is an altitude of triangle PCA. So therefore, we have our right angle at PCA. Okay. Now these are super challenging theorems for students. So if a point is on the bisector of an angle, then it is equidistant, meaning the distance, when I draw my perpendicular, is equal from the two sides of the angle. Meaning, if I have a point on the bisector of an angle, so D is on the bisector of an angle. So which angles are equal? DAB and DAC. Those two angles are equal, then DB is equal to DC. Now if a point is in the interior of an angle, so I have point D is in the interior of the angle, and equidistant, meaning when I draw from my line perpendicular to the side of my angle, line perpendicular to the sides of my angle, is equidistant from the sides of the angle, then it lies on the perpendicular bisector. So if BD is equal to DC, and these have to be right angles here, and these are right angles, then the measure of angle BAD, then we have an angle bisector. Okay, the points where the angle bisectors meet of a triangle meet is the incenter. The incenter is always inside of our triangle. And why is this point important? So when I draw in my angle bisectors, I'm going to kind of sketch them in as best I can. Apologize, it's not going to be perfect. They're not perfectly straight lines. This point is then equidistant, meaning I'm perpendicular there, from all the sides of my angles, so that I can draw a circle inside of our triangle. It's called an inscribed circle. It's inside tangent, meaning hits only at one point, inside of our circle. Okay, complete. If BX bisects angle ABC, then so BX is our angle bisector, so then ABX is equal to CBX. And then, so then X is on my angle bisector. That's the angle bisector. I have a point on my angle bisector that goes and is perpendicular to one side of my angle. So therefore dx is going to be equal to xg. Because x is on my perpendicular bisector, BC is one side of my angle, AB is the other side. When I draw my perpendicular, they're going to be equal to the sides of the angle. Okay, next. dx. dx is the perpendicular bisector of EB. Then ED is going to be equal to DB. And XE is going to be equal to XB. Because X is on our perpendicular bisector, we're equidistant from the endpoints of our segment. Okay, if XB is equal to XF, okay, so I have two segments that are equidistant from the endpoints of segment BF, then XG is going to be our perpendicular bisector because that X is on segment XG. And XBF is equal to XFB. Because we have two angles, our two base angles of our isosceles triangle. Okay, next. If XD is equal to XG, so I have these segments equal, I have perpendiculars to that segment and to that segment, therefore X is the bisector of angle XB is the bisector of angle ABC. Okay, real quick proof. Prove that the medians drawn to the legs of an isosceles triangle are congruent. So, given, prove, and I'm going to draw a picture over here. So I have medians drawn to the legs of an isosceles triangle. So triangle X, Y, Z is isosceles. I was thinking about my width. Isosceles. Now give me my congruent parts with XY congruent to XZ. So you need to list the congruent sides when you give me that piece of your given. Now we also have to draw in our medians. YA is a median and ZB is a median. we want to prove, so the medians drawn to the legs of an isosceles triangle are congruent. So we want to prove that YA is congruent to ZB. Okay, triangle XYZ is isosceles. I'm okay if you don't write that piece. I'm okay if you just put XY is congruent to XZ, and you can also put YA and ZB are medians. And we are given that. Second step, write something about the given. Okay, probably the triangles I'm going to want to prove congruent because I'm trying to prove YA congruent to BZ is triangle BYZ, and you might want to pull those out. Congruent to YAZ. Okay, so we're going to try and prove those congruent. The pieces that are AF congruent is my base. So my bases are equal. If I could get this big angle here equal to that big angle, I'd be golden. Well, how do I know that? Write something about the given. I know angle XYZ is congruent to angle XZY by ITT, our isosceles triangle theorem. So I now have angles equal listed in our proof. Let me list out our reflexive step. Okay, next, I need to get, because it looks like I want to use side angle side, so I need to get YB equal to AZ. Well, what do I know from the second part of my given? I know that by definition of median, B is the midpoint of XY, and A is the midpoint of XZ. Now you could go the long way with this. I'm going to go a shorter way. We know by our midpoint theorem that since I'm trying to prove YB equal to AZ, that YB, the length of YB, is half of the whole segment. And same thing with AZ. So then from there, I need to get YB equal to AZ. I know XY or YX is equal to XZ, so therefore by multiplication 1/2 XY is equal to 1/2 XZ, and that is by either multiplication or division. Then next, since 1/2 XY equals 1/2 XY, YB is equal to AZ. So now we have our triangles congruent. That was by substitution. Now our triangles are congruent. By side angle side. And then we can say that our pieces are equal. by C, P, C, T, C. Now what you need to remember is it's not really a shortcut, it's just a theorem that you guys often forget about, the midpoint theorem. You could go through and say that YB equals BX and XA equals AZ, and then add them together and divide by 2, but you're really just reproving that midpoint theorem. Okay, no lesson questions for today because we did that Geometry Sketchpad activity. And there you go. I was going to say make sure your lesson summaries is submitted on time, but you don't need to worry about that.